Good afternoon, Year 10. This is me. It's the day before Christmas, trying to break up. I'm still here, so you better watch this video, okay? What I'm going to do is I'm going to go through some of the difficult science words which you might encounter in your examinations. So I'm going to hold them up one at a time, and I want you to pay attention to what the word is and try to understand what it means, okay? So our first word is hypothesis. You see that? Okay? Now, hypothesis is a scientific idea which somebody might have. It doesn't necessarily mean it's correct, it's just an idea. So, for instance, if I said, my hypothesis is that the larger the amount of antibiotic I took, the quicker I would be cured of a particular disease. That would be a hypothesis. It doesn't mean it's correct because it hasn't been tested yet. Okay? Second word we're looking at is mean. Now the mean means to take the average. The reason we take the mean is because it gives us more reliable results. The way to take the mean is to add up how many numbers you've got. So for instance, if I took 4 repeats like so, to calculate the mean I'd simply add them all up and divide by 4 because there's 4 numbers there. If I had 3 results, then obviously I would divide by 3. And that's how we calculate the means. Okay? Next word is this one, outlier. Now if you look at my graph here, you see all the points on the graph follow this line here. And there's one point here which doesn't quite fit the pattern of the rest of them. This is called an outlier. So if the question asks for to identify any outliers, look for the results which don't fit the pattern of the rest of the results. Okay? That's outlier. Next word, or 3 words actually, we have correlation, factor, and outcome. Now again, if we look at the graph, okay, a correlation is a pattern that we see between 2 different factors here. So, this is the concentration of the antibiotic, and this shows the percentage of bacteria killed. So, if it asked, is there a correlation in that graph, you could say yes there is, because as the concentration of bacteria increase, we know they're increasing because this arrow shows that it's increasing. The percentage of bacteria which are killed also increases. That is the correlation, okay? If you're asked to describe a correlation, all you need to do is this. Put the words as the next to the x-axis, and then just say what it says there. So as the, whatever it says there, okay? Now if the line is going up, it's increases, okay? Remember, if the line is going down, it decreases, and if the line stays like that, it means remains constant. So we can say, as the concentration of antibiotic increases, the percentage of bacteria increases, decreases, or remains constant. Okay? That's what correlation means. Now, the factor is the thing which actually causes it to change. So in this case, we've got concentration of antibiotic, but we could also have type of antibiotic. Okay, that would be another factor. We could have, I don't know, the temperature of the treatment. All these things would be factors which affect it. The outcome is quite simply what happens as a result. So the outcome for here is factor concentration, outcome, more bacteria are killed. Okay? So those are the words concentration, factor, and outcome. Now, this is a bit of a complicated one. You see that? Individual, sorry, there he goes. Individual case not giving convincing evidence. What this means is, if you have a study, okay, and said, does this study provide sufficient evidence to make a conclusion, we could possibly say no, because we're only looking at one individual case, one individual scientific experiment. To make the results more reliable, we'd have to repeat this individual experiment, wouldn't we? Yeah? And preferably different scientists actually repeating it in the first place. Okay? And that's what I mean there. And sample size refers to how many people or how many products were actually tested. Okay? Now, for an experiment to be reliable, the sample size has to be quite large. So for instance, if we done this test on, I don't know, maybe 3 Petri dishes, those little dishes we grow bacteria on, then maybe, to make the experiment more reliable, we'd have to use a larger sample size, which means we would use more Petri dishes. Okay? That's sample size. Deduce. There we go. Bring it closer. Deduce means what can you find out from these results? Okay, what are your deductions? What are your conclusions? Implication. Okay? Now the implication means what is the outcome of these results? So for instance, what is the implication that increasing the antibiotic concentration kills more bacteria? Well, the implication would be that we need to use high levels of antibiotics. Okay? So the implication means what is the result of the outcome? What happens as a result of it? Scientific claim. Okay? Now a scientific, whoops, there we go, there it is. A scientific claim is something which is stated by a scientist which has not been tested yet. Okay? So for instance, if this antibiotic was called antibiotic A, the manufacturers might make a scientific claim that antibiotic A is more efficient at killing bacteria than antibiotic B. It remains a claim until they've actually provided evidence which is reliable. Okay? So it hasn't been tested yet. Plausible. Plausible just means if something is possible. So if you ask me, is it plausible that I'll pass these examinations? And I said, yes, it is possible that you could pass these examinations if you watch these videos and you actually do some revision from your revision guides. Okay? So plausible means is something possible. And this is an important one. You see that? There you go. It's called peer review. Okay? Now a peer review means that whatever you do is judged by those in a similar standing to you. So for instance, if I was to be peer reviewed, then I'd be observed by other teachers who would give comments on my performance. If you were to be peer reviewed, then you'd be watched by people in the same class as you, or the same year group as you, and judged on your performance. Okay? When we use the term peer review in science, we're pretty much talking about scientists who carry out studies by other scientists. Okay? Now the best way to peer review is by publishing the results in a journal or in a scientific paper, or sometimes they publish their findings at a scientific conference. Okay? So that is peer review. Next, consequences. Okay? The consequences just simply means, as a result of whatever happens, what are the consequences? What is the implication for the future? So, for instance, if we're talking about, I don't know, devising a test for testing for a faulty gene, what's the consequences of doing this? Well, it may well be that it's going to lead to, I don't know, a greater incidence of abortions, because people will be aborting children that they know have a faulty gene. So that's a consequence, okay? What are the consequences of smoking? Lung cancer. So something possibly happens as a result of what's been looked at. Now you see this word a lot in examinations. There it goes. Okay, there it is. Organism. An organism just means a living thing, anything. It could be a plant, an animal, whatever, it's called an organism. This is an interesting word. Perceived risk. A perceived risk is the risk that people feel is attached to a particular activity. So for instance, people think that parachuting out of an aeroplane is risky, when actually it's not. People perceive that air travel is risky, but it's actually not. Okay? So it's a risk that people think exists. Calculated risk is the reverse of this, if you like. It's the actual probability of something happening. So for instance, as I said, when we're talking about air travel, the calculated risk is very, very small. But then when we're talking about smoking, the calculated risk of actually getting lung cancer from smoking is incredibly high. This doesn't stop people from smoking, does it? Because the perceived risk from smoking is quite low. Controversial. Something is controversial if it stirs up a debate in the people around it. Okay? So for instance, if Gaberhall School made the decision that all students had to come to school at 7 o'clock in the morning and leave at 7 o'clock at night, like me, then that would be controversial. Social context. The social context means how any decision affects society that we live in, okay? So for instance, if the government decided not to vaccinate children anymore, what would be the social context of that? Well, it means that families in the country would suffer as a result because their children would then get these nasty diseases which we can't be protected against, okay? Correlation, we discussed earlier on. Remember, there's a pattern in the data. So always, if they say, what is the correlation? Just look for a pattern in the data. Now, this is important. Opinion. Now, sometimes they show you a passage of text in the examinations, and they say, underline any statements which are opinions. Okay? So, for instance, if I said, Welsh people are the greatest on earth, that's not necessarily a fact, is it? There's an opinion of me. Okay? If I said the Welsh rugby team is the best rugby team in the world, again, that's an opinion because it's based on fact. Okay? So don't believe that everything that somebody says is actually the fact, it's an opinion. Justify. Now, this is where opinions, okay, can be put to the test, because if you're going to justify a statement, what you have to do is provide data to back up what you say. So if I said, for instance, the Welsh rugby team is the greatest rugby team in the world, how would I justify that? Well, I couldn't. But I would have to come up with something such as they've won the last 3 World Cups, okay, and that would provide evidence for my opinion. So those are the big science words that you need to know for your examination.